Hello everyone. Today I will going to design a spiral column. Here is the question of the spiral column. The interior column is shown. Here is the interior column shown in figure here. And the 5 stories building. The building will be constructed 5 stories. In office building is required to design. Okay. The building is constructed with flat plate slab and thickness. The dimension of the slab panel surrounding by the column is shown in the figure. Here is the dimension 8 meter, 8 meter, 8 meter in x direction, in the y direction, and the same way in the x direction. The slab panel is 8 meter. Okay, and the slab thickness of the slab will be 250 millimeter. The stiffness 37 including flat finishing, and the live load is given 2.4 kilonewton per meter square, and random wall is 3 kilonewton per meter square. And assume data is required to design as a spiral column. So we will see the spiral column, how to design a spiral column. Okay, so let's start. Here is a step 1 is a design 1 slab thickness equal to ln divided by 30. Ln means the longest span, and the 38 into here is the longest span. All the span is given to all the span is 8 meter. So we have found 267 millimeter, and we lose 250 millimeter. Even though the question is given here the 250 millimeter in slab panel thickness, but we have found here the same value. Okay, the depth will be self weight of slab, floor finishing, and random wall. So slab self weight is mean 250 is thickness of the slab, and 24 is the unit weight of concrete. 8 into 8. 8 means the in the y section, here is the half of the slab panel, and here is the half of the slab panel. Half means the 4. 8 divided by 2 into 4. 8 divided by 2 into 4 in the y direction. In the same way we have found in the x direction, slab panel divided by 4 and slab panel divided by 4. So we have found the 8 meter. So this is called tributary area or tributary area of the column. The column will be taken this force from this area, 8 into 8, and 5 in the number of stories. We have found here that we will design the 5 stories column. That's why we will use the 5 stories. And the floor finish we have the thickness of floor finish 50 millimeter and divided by 1000, which is goes to meter, and 24 is kilonewton per meter square is a unit weight of concrete, or ampere, 20 ampere. And 20 ampere is a unit weight of concrete, and 8 into 8 into 8 tributary area of the slab, and 5 into the 5 is means the number of stories, and 3 is given here, given the random wall. Here is a 3 kilonewton per meter, or we will take the take value from ASC 7 or ACI 318 or BNBC or others local code. And 8 into tributary area, and 4 is the unit number of stories. The random wall will not provide at the top of the building. Here is the 1, 2, 3, 4, 5. So all the stories will use the slab panel, with slab and floor finish, but random wall will not provide at the top. That's why we will use these 4. Otherwise we have used 5 and 5. Okay, so we will get the 3072 kilonewton, and live load 2.4. 8 into tributary area, 8 into tributary, and 5 into number of stories. 2.4 is given here, 2.4 kilonewton per meter square, but we will taken this value from ACI 310 or ACI 75 or BNBC or local code. So ultimate load will be 1.2 dead load plus 1.6 live load, which is found 4915.2 kilonewton per meter. So assume this column size number. So we'll go to step 2, assume the column size. So P equal to 0.75 into 0.85 into 0.85 into FMC. 0.85 FMC is assumed for we have assumed that all the force is taken only concrete, not steel. Steel will not participate. That's why we will call the assume column size, and we have found 302357 kilonewton per millimeter square. The assume column LM dimension or column area, and we have Ag equal to pi d square by 4, and putting this value Ag, and we have found that T equal to 25620 millimeter square. This is This is only for only for column for taking the concrete force, but we know the column will also participate still also taking some force. That's why we will assume another 565 millimeter square. This is assume value, or let assume value. This is assume. We have taken the reduced value. Why we will reduce this column dimension of the column? Because we know the column will also take the reinforcement will take also some forces. That's why we will reduce this. Otherwise we have found this only for the concrete will take the force. Okay, so the new gross area will be pi by 40 square, which is 250719 millimeter square. And calculate reinforcement. We have found this Pu equal to 0.75 into 0.85 into 0.85 into F CIG minus AST into Fi into AST, and we have put all the value and find the reinforcement 3338 millimeter square, and rho equal to 0.013 0.013 is greater than minimum value and less than maximum value. Here is the value minimum value 1% or 0.01, or 6% 0.06. We will get this value as C705 or ACI 31808 or BNBC or other local code. Okay, so our rho value is okay. So now we're going to design the reinforcement. So step 4 is the reinforcement details. We will using 20 milli ms bar, and the area of ms bar 314 millimeter square, and number of bar will be here the reinforcement here 3338 divided by used bar, and we will got the 5.60, but we will use the even number, which is 12 bar. So we will use 12 bar as a main bar. So now we will go to the spiral spacing of the spiral at the spiral bar design, but we can call the spacing of the spiral bar. Okay, so DC equal to DC means dia of core bar equal to D dia minus 2 into covering. Here is the two side of the covering will be reduced. 565 minus 2 into 40 equal to we have assumed that the covering will to 40 millimeter. That's why we have found the 485 millimeter. Okay, let's see the another the area of the concrete as core area pi by 40 square equal to 4 by 4 400 millimeter square, and found the 184745 millimeter square, and rho s equal to 0.45 f prime c fy AG minus SC D minus 1 AG by SA minus 1, and we have put the all value and found 0.011, and we have already found rho value 0.013. Here is the our value rho value, and we have found the 0.01. So this is the less than of the our provided rho value. That's why the value is okay. So spacing of the spiral bar, we have used the 10 milli spiral bar. The area with but 10 milli spiral pi by 4 10 square, which is 78.5 millimeter square. So the spacing we will taking the spiral bar equal to 4 into S divided by rho S into DC. So 4 into 0.785 S equal to 0.01 and 485, which we have found 59 millimeter center by center. And another one is spacing has found is S equal to DC by 6, which is 485 divided by 6, which is 81 millimeter center by center. There we have taken the one only minimum value, which is 10 milli spiral bar used at the rate of 59 millimeter center by center. This is our picture. The dimension 565 millimeter, and we have used that main bar is 12 number of 12 bar 20 milli main bar have used, and 10 milli spiral bar used 59 millimeter center by center. Okay, so this is the this is the spiral bar design. So you can take a shot or screenshot here for your study purpose. So we will check the comparison between tie bar and spiral bar. We have seen the lecture, previous lecture we have designed the tie bar, and the today's lecture is spiral bar. So we will compare why the value is reducing, or what is the comparison. So we have seen the ultimate load is same, 4915.2 kilometer, and H equal to 3706 in 79, which is 609 into 609, but we will assume the 5 into 5. We have found 609 and 609, but we will use 5 into 5. And in the same way we have used found 3029 millimeter, which is dia 62 millimeter, but we have used 565 millimeter. So we can say that 2507, which is 250719 and 250040, this value and this value almost are same. We can say that the area of the column, tight column and spiral column, all the two area are the same, but we have found the steel area is the different. The tight column has found 7,820 and 3,338, which is almost half of the tie bar. So we can see that the half of the tie bar, the steel is less, more less is required in the spiral bar. On the other hand, is more and more needed in tie bar. So the rho value is found 0.03. On the other hand, we have found rho value 0.01. So we have found 27 bar of 20 milli main bar. On the other hand, we have found only 12 bar of main bar. So we can see the tight column is very expensive. On the other hand, we can see the spiral column is very less, very economical. On the other hand, we can see that spacing tie bar to 10 milli tie bar, 320 millimeter center by center, and the same 10 milli spiral bar used to 59 millimeter center by center. So we can conclude that the spiral bar is more economical. So we have assumed another my assume value, or my I have, what I will say, self study that we have found here the rho value is 0.03. If I will use the rho 0.03 in spiral bar, then what will I found? Then I will found a 24 bar, which is very close to 26 bar. So we can conclude that the value is varying on the value of rho. So rho value is very important for us. So if we change the rho value, then our reinforcement will be changed also. So thank you. So this is not, you can use not, or you can study yourself here for your enhancement or your development. Thank you everyone. If you have any question, then comments here.